Hey guys, how are you doing? My name is Aline. I'm from south of Brazil, from Porto Alegre, and I'm a senior TA applicant. Now I want to talk about a subject that is one of the most challenging for me in the PPCR, that is linear regression. I hope you like it. I like to say that linear regression is a method that has the ability to predict from your data. Let's say that you were studying a population of mice and you want to know the relationship between the size of the mouse and the weight. In other words, are the bigger mice also heavier and vice versa? Here is our hypothetical data set. We have 9 mice and their sizes and weights. So, how to use regression in this case? Regression is related to a prediction, right? You can predict a continuous variable, size for example, from another, weight for example. My objective with this is to check how well my data prediction fits in a line. In other words, does it can be predicted by a line? Okay, let's plot our data in one graph. In the y-axis we have size, the dependent variable that we are trying to predict, and the x-axis we have weight. The dots represent each subject. This red line is obtained by the list of squares, that is something calculated by your statistical software. But just for curiosity, you don't have to calculate this by hand, of course. The sum of the squares is the sum of the distance from the real value, from your sample, to lines with different inclinations drawn through the data. When you plot the sums in a graph, you can see which one is the least of squares. The line related to the sum is the line chosen to be the fit, or the line that best represents your data. That is the red line. So, back to our linear regression. Another thing that you need to check is how well this line fits in our data. For that, we have the R2 that is represented by this equation. R2 equals to variation around the mean minus the variation around the fit divided by the variation around the mean. What is this variation amount around the mean? If you consider just size, that is our main variable, our dependent variable, the distance from the values to the mean size, residuals, divided by the number of subjects, that is our sample. This is the variation around the mean. The same thing for the variation around the fit. We can do that with the red line. So R2 is going to be a number between 0 and 1, meaning or from 0 to 100%. If for our sample, our R2 is around 60%, it means that mouse weight explains 60% of the variation in mouse size. Putting that in Stata language, using the command regress, the independent variable and the dependent variable, you will obtain this table. Let's explain it. For our model, you have the sum of squares of the residuals here. Remember, the distance from the values until the red line. We have our R2 that is 0.67 or 67%, meaning that the weight explains 67% of the variation of the size. And what are these two coefficients? This one is the constant that we are going to use in the equation to predict the data. The second coefficient we are going to use in the final equation along x. So to sum it up, the final equation that would predict size according to this sample is y, the dependent variable, that is size, equals to 2.28, that is the slope, a numerical representation for the inclination of the curve, and the number by along x that is weight, represents the amount of variation in weight to vary 1 centimeter in size. A little review. What are the elements of a linear regression? First, we need to see the relationship between size and weight in a scatter plot. Look for the fit, that is the line originated from list of squares. And we are gonna need the R2 that tells us how much the weight explains the size. In this data, you also have a statistical test to check if the R is significant. Look for the coefficients, the slope, and the coefficient along the x. And finally, you have your equation to predict from your data. Thank you guys. That's all.